Yeah, well, anyway, but yeah. Apologize. Yeah, so-called agitation.
Dude, it's throwing me off.
Our printer upstairs was out, so I get these printed somewhere else.
I told you.
Anyway, other questions? You have
Can we work 3.2.4 from the number
3.2 point what?
4?
Okay.
It's the amplitude 5 volts, frequency is 10 megahertz,
5 volts, F naught is what?
10 megahertz. The rise time and fall time is 10 nanoseconds. Duty cycles 50%. Hang on, I'm logging in.
What?
Hang on, I'm logging in.
I'm sorry, what?
She's logging in to get the rest of the
What
info.
else is, can anybody else tell me?
And we're supposed to find the capacitance value with,
What's the circuit look like?
it's voltage source that has got 1 kilo ohms coming from the voltage source.
Plus minus square wave, right?
Yes, sir.
VS, it's got a resistor R, right?
Yes, sir.
And then a capacitor, resistor,
Yes, sir.
okay.
And find the capacitance at the 5th harmonic.
Well,
That's where
then
it's
it
by
accomplishes
20.
something, right?
Yeah.
Reduced by 20 dB.
All right, now, this is a good problem for a lot of reasons. I'm just gonna put R is equal to 1 K ohm. C is undetermined, right? And they want this, they're saying they want the 5th harmonic to be down by 20 dB, correct? So 20 dB from the 1st harmonic, I'm assuming, right? Y'all follow me on this? Now listen to me. If you read, just listen to the problem and think about it. The rise time and fall time don't have anything to do with that. And I'll show you why. The only thing you care about is the frequency. Y'all follow me on this? So let's do it this way. And I want you all to follow me on this. I'm going to take a look at these 2 parallel components. And I'm just going to call these ZRC, the impedance of that branch. Do y'all follow me? And ZRC would be equal to, now those are in parallel, so the impedance of this is just 1 over J omega C, isn't it, class? Y'all with me on that? And therefore, if it's the impedance of 2 in parallel, it's 1 over the impedance of the first plus 1 over the impedance of the second. Make sure you all agree with that, what I just put down. There are people that don't see that sometimes and they're afraid to ask. Does everybody understand what I did? 1 over the impedance of the first plus 1 over the impedance of the second. Y'all got me? And that would be equal to simply R over 1 plus J omega R times C. Do you all agree with that? I multiplied top and bottom by R. Agreed? Now, leave that alone. The transfer function H of omega would be equal to that impedance. Please watch this. Make sure you see what I'm doing and why I'm doing it. Divided by Z RC plus R. And that is the ratio of V out over V in. I want to comment on this. First, you all agree with what I wrote? Everybody? All right, now I put it in terms of ZRC for a reason. I want you to watch this so you can appreciate it. I'm going to divide top and bottom, and that's equal to V out over V in. We know there's a 20 dB reduction at the 5th harmonic. But first, I want you to focus on the transfer function. This will give us all our information. Now, this would be equal to 1 over 1 plus R over ZRC First, convince yourself if I divide top and bottom by ZRC, that's what you get. I want to make sure you see it. And what I'm going for, based on a lot of stuff I've done for the last 30-some years, is trying to simplify this. Always remember, as engineers, try to simplify things as much as possible so you see what's going on. Don't ever make them complicated. Now, I'm going to plug in that in here. Now, please watch this. So that means that's 1 over 1 plus R over ZRC, which is what? 1 plus J omega RC divided by R. You all agree with that? I'm just plugging in that ZRC. Do you all see this? Can you all in the back and everything see this, right? Now, what is the one thing that's obvious?
R cancels.
You all see how R cancels, right? That's the reason I'm doing it this way. So that means this is simply equal to 1 over 1 plus 1 plus J omega RC. Y'all got me on that? All right. Now, you can simplify that, and that's what? 1 over, if you want to, 2 plus J omega R times C. And I think you all agree with that, right? All right, now what does he really say in that problem? He wants a 20 dB reduction in the level from the first harmonic to the fifth. Agree? So what is the level? And I'm going to do it this way. I could say V out is H omega times V in, right? But if I think about that, and I'm going to do it right here. If I have V out, you don't have to write this, but I want to make a point here so you can appreciate it. What I'm doing here is so important. V out is equal to, did you have a question? You can ask me.
So the problem asks for a reduced 20 dB in the gate voltage, which is the voltage across the resistor on the far side.
It's this, right?
Just
They're
the
in
resistor.
parallel.
Just, yeah, but it's asking for it in the resistor. It like leaves the capacitor. Oh,
They're in parallel.
Yeah, that's
aren't
right.
they? Y'all agree with that? Doesn't matter if the
Because there's no
voltage is
same
here or
voltage
here.
across
If they're
it.
in parallel, it's reduced.
Yeah.
That's the only thing that matters. All right, so V out would be equal to H of omega times V in, right? Now that's linear. Now if you take what? 20 times the log of that, divide by 10 to the minus 6, because I want dB microvolts. Y'all with me? Then you get 20 times the log here of the magnitude of V out over 10 to the minus 6, right, is equal to, I'll do this, the first one, 20 times the log of magnitude V in over 10 to the minus 6, right? Then it's going to be plus 20 times the log here of the magnitude of H of omega. Do y'all agree with that? All right, now when we talk about a logarithmic reduction in the output, and it really wants the fifth harmonic to be 20 dB below the first harmonic itself, right? What you're going to see is this is the same, I mean that will have the same, you might say values for whatever I'm sorry, this has the same frequency signature that we know from before. It looks like basically this, right? Y'all agree with this? Now if we take that and we take a look at the value of the output when this is at, say this is the first harmonic, at F naught, right here. Whatever this value is that we reduce it, the only thing we have to do is find this value right there. We have to find this value and simply reduce it by 20 dB. Does this make sense to you what I'm saying? In other words, this plays no role in that. The only thing we need is F naught. Just listen to me. They want the value of the first harmonic to be reduced by 20 dB because of that capacitance, all right? So here's the real game with this one. I'm going to do it here. And I'll admit, it would be better in some senses if they gave a signal level that they desired at the fifth harmonic at the gate, but they don't. They just want a reduction from the first to the fifth because of that capacitance. So here's what happens. Right here. I take a look at h of omega naught, that'd be the first harmonic. It's 1 over 2 plus j omega naught r times c. Agree? Then I take a look at the fifth harmonic. Agreed? I want 20 dB reduction, right? In these two values, correct? What is a 20 dB reduction? Well, that would be 20 times the log of h of 5 omega naught over h of omega naught would be equal to minus 20 dB, right? And that, y'all follow me on this? That's a 20 dB reduction, isn't it? So what is it going to be? Well, just put the values in here. What do you get? 20 times the log of the magnitude of this, right here, which is 1 over 2 plus j omega naught times 5 times RC. And it's divided by that, where this goes up top, 2 plus j omega naught r times c is equal to minus 20. Do y'all agree with that, everybody? Y'all follow my thoughts on this?
I don't follow you. How
What do
do,
you,
how does that just automatically equal minus 20 dB?
you know when they say a 20 dB reduction, it means a reduction is a negative, right? So if I make this equal to minus 20, that's a 20 dB reduction, right?
Mm-hmm.
Because dB always is 20 log of something if it's voltage ratios, right? Y'all follow me on this, class? How many do? Y'all, you don't see it, Clay, or what?
No, I think I understand what you're saying now. I wasn't, he asked a question I was thinking.
And you answered it because you're saying not that the left side equals the right, but that we already know the answer
Well, I
to the
said
right.
they give us that.
Yeah.
All right? And that's the reason I put minus 20. They told us how much they wanted to do. If they wanted minus 40, we put minus 40. Y'all follow me? And a reduction is negative. An increase would be positive. That's the difference. Now, if you're not used to thinking that way, I understand that. But a lot of your upper level courses are going to use that terminology. I want to tell you one other thing. Dr. Reeves is retiring. Dr. Riggs is retiring. Dr. Hung is retiring. I think Dr. Hung's retiring next fall. But Dr. Reeves and Dr. Riggs won't be here in the spring, which is news to me because I don't know who's going to teach the courses. I'm telling you, it's all happened because of this vaccine stuff. But I haven't been told that directly, so don't quote me on that. It's just a whole lot of people are all of a sudden, they're putting in their paperwork and the Bahamas are looking better and better. Y'all with me on this? So, now, can you all see how, if we know R, can't we solve for that value of C based on what I just showed you? How many see that? All right, I'm gonna take us through this, but this is such a good question. What, you don't sit, or you do sit?
No, I'm just surprised Dr. Reeves is retiring. I'm
Hey,
like,
look, it doesn't, in a way, it's I'm not saying that vaccine did. Don't quote
Yes,
me.
sir.
It just seems coincidental that out of the blue, all of a sudden, I retired. Gosh, I retired. Had a great job. Somewhere in Florida.
The 5 omega naught, is that supposed to be on the top instead of the bottom?
Look at this. What is
Okay.
h of 5 omega naught?
Yeah.
Okay, that's the reason. But I understand why you're thinking that.
Yeah.
Y'all follow me on this, why I did it? All right, let's go find out. Me and that camera, all of a sudden, they're not doing well.
You just remembered it?
No, I just thought about what I just said.
Let's take one.
Why? Can I get a letter? wouldn't be the first time. How dare you? No, y'all agree with that? That's log base 10, right? So we take both sides, 10 to both sides power, we get 1. So we get 2 plus j omega naught r times c over 2 plus j omega naught times 5 times rc is equal to, and then 10 to the minus 1 is simply 1/10. Do y'all agree with that? I'm just showing you the math, right? All right, to solve it's pretty straightforward, but it's up to you how you want to do it. If I do that, and it's magnitude, remember, right? So if you want magnitude, probably the easiest thing to do is a simple multiply both sides by 10. Let me do it here. There's probably a lot easier way. So F naught is 10 megahertz. So not that. So we have 10 times magnitude of 2 plus j omega naught r times c is equal to 2 plus magnitude of 2 plus j omega naught times 5 times r times c. Do y'all agree with that, class? Work with me if you, y'all follow me? Here, I gotta make sure I put magnitude. Now, if you got magnitude, that means what? Well, it's 10 times square root of, and the magnitude of this would be 4 plus omega naught squared times r times c squared, right? Equal magnitude of that will be square root of 4 plus omega naught squared times r times c, right there.
Add that 5
squared
back in.
Times 25, right?
Yeah.
I'm trying to break RC out in front. Y'all agree with that? I'm just doing this is straight math here. And then at this point, I guess you could fuss with it, but I'm going to square both sides. If you square both sides, I get rid of this square root. This becomes 100, right? Y'all agree? Yeah.
Isn't j squared -1?
Well, how do you get a magnitude of a plus j, b? Isn't that square root of a squared plus b squared? Because what does this represent? It represents a and jb, and this diagonal is the magnitude of a plus jb, isn't it? Good question, though. By the way, engineers are notorious for doing what you just said. They just write an equation, I know it's square this plus square this square root, and they'll square the j when they write these things. If you're just like in that mode of doing C programming or something, you know the equation, and you don't realize that, you make a mistake. So good point. All right, so now that I have that, what happens? Well, up to you, how you want to do it. Probably the best thing is multiply. You get 400, right? Plus, and this is going to be 100 omega naught squared RC squared is equal to 4 plus 25 omega naught squared RC squared. Agreed? Just work with me. Y'all agree with that? Some of you see a quicker way to do it? Probably. All right, I'm going to subtract, first thing, 4 from both sides to get rid of that small thing right there. So that makes this what? 396, correct? Now after that, what I'm going to do is, boy. Something looks wrong here. I'll tell you why. Because on the other side, this is negative. Did I make a mistake somewhere?
Here.
Huh?
Oh, no.
It just didn't drag that -1 to the 110, so it didn't
No.
carry.
Oh, 10 to the -1 is 110.
All right.
Oh, that five wasn't squared. Oh, yeah,
Yes,
that's
it was.
All right, let me see what happens here.
You distribute it when you want.
Hold on for 1 second.
Computer program.
Oh, you know what?
He's stuck until he figures it out.
20 dB reduction, so what I should have here is the H of omega naught here over H of 5 omega naught here if it's a reduction. Follow me on that?
So that would be omega naught.
Wait a second, maybe I'm wrong about this.
No, that's right, because
Hold on for 1 second.
5 omega naught's supposed to be the smaller. 5 omega naught minus omega naught should be the smaller.
If I take a look at this, 20 times the log of magnitude of H of omega naught, I get this value, 20 times the log of the magnitude
So the way he had it,
1
he should have
over
plus 20 on that side.
1 plus J omega naught R times 6. That's it. That's the magnitude there. If it's a 20 dB reduction in that, that's a factor of 100, right? 20 dB is a factor of 100.
Yeah.
Y'all follow me on this? If you talk about dB, 0 dB is a factor of 1, right? And if you're trying to do this in one, if it is voltage, 20 dB reduction, 20 dBs per decade would be an order of magnitude or factor of 10, right? So if you took this value, and I made it 1/10, that should be this value. And I gotta find out what I did wrong here. I'm feeling it's very simple, but, and that should be what we had over there. I'm just checking. So if I want to solve for C for this equation, I want magnitude. Multiply by 10, I get this. Cross multiply, I think this is what I had, didn't I?
Yeah.
Oh, but it was 2, wasn't it?
Yes.
Oy. I think I know the problem. I should have done is put the half up top.
Yeah.
I'll get to that 1 second. Look at that. This thing up.
And then you're
So 70 degrees.
Sun's pretty bright today. It's the lack of clouds. I would love to watch this video. Just having conversation.
You know what? I squared the 10, but look, it's the magnitude of this, not that. Is that where the problem is? Because this should be, this, let me just try this. I think that's right. If I look at this, this is 10 times the square root of 4 plus omega naught RC squared is equal to the square root of 4 plus omega naught RC squared times 25. Isn't that right?
So then we add the square of everything, so.
But it will get rid of, it'll leave these squared, but it'll square the 10, right?
Yeah.
And
It's gonna be the same thing.
Yeah.
That's what we want to do.
will that work then? Let me just see here.
No, you'll still end up with a negative.
If I go ahead and there's a 2 here, make that 20. Right? Y'all follow me? This is a 1. I took a 1/2. This is 2, so I factored. This is 4, correct? So I got omega naught over RC squared. I factored out, that was a 4, square root of that is 2. I factored that out. I got 20, and I'm going to get rid of that 10. I'm just going to see if this actually is going to work. It should, but let me just see here. No? Well, maybe. Wait. Let me just see here.
Right. Put it in.
Technical difficulty.
This works. Doesn't
Oh,
work.
it's not that.
All right, I'm gonna stop there. I'm not sure what I'm doing wrong to be on the level with you. I've done this problem, and I think I'm doing it right, but there's obviously something I'm not doing, because the simple way to get this is, if I take the value of h of omega with that r, I can tell you this works. If I take h of omega naught, that's simply gonna be 1 over 2 plus j, and then omega naught's known, so omega naught r is known, right? C is the unknown, correct? That's it, right there. If I take that, as I increase frequency, with that right there, whatever that value is, when I increase frequency, I want that value to go down at the 5th harmonic to be 20 dB below that. Oh, I know why. You didn't read that problem right, I don't think. Could you read that problem? That's the 5th harmonic from 0, not from the F naught. I think that's it. The reason is listen, things fall down at a minimum of 20 dB, listen, per decade. We're trying to get 20 dB for 5, or for, what is it? Instead of 10 F naught, 5 F naught, for an RC circuit that can't work. We're asking something that's impossible with just an RC. You need an inductor. Go ahead.
It says determine the value of the capacitance such that the 5th harmonic is reduced by 20 dB in the gate voltage.
Yeah, and what they're not saying explicitly, I'm assuming it was from F naught, it's from 0. That's the problem. Here, you'll see this work now, I believe.
So 4 omega naught?
Just watch. This is equal to, if that's just omega, do you all agree that's the transfer function for the circuit I had there, right? All right, so what's h of 0? That's simply 1/2, isn't it? Y'all agree with that? Now, we want this value to be reduced by 20 dB, or 1/10 of it. Y'all follow me? 20 dB reduction would be a 10th. So if we take that value, I'll do it here. 1/2, and I divide it like this, we want that equal to the magnitude of that transfer function, which is 1/2 plus j omega naught r times c times 5. Y'all follow me? That'd be the fifth harmonics value of that? Now, if you look at this right here, that's 1/20 equal to 1 over the square root here of 4 plus omega naught times r, times r. No, I'll put it, yeah, times r squared times 25 times c squared. Y'all agree with this? All right, now listen, this I believe is gonna work. First, I'm gonna go ahead and square both sides. Sorry for taking so much time. Y'all agree with that? Now, after that, I'm gonna flip them. And when I flip them, I get what? 400 on this side is equal to 4 plus, and this is gonna be omega naught squared, r squared times 25, and c squared. Y'all agree with that? Now you're gonna see it works. I bet you we get this right on a button. I'm gonna take 4 from 400, get 396. Y'all agree? Now, after that, I get all the unknowns and divide them into that. So I'm gonna divide 396 by r squared by omega naught, or 2 pi times 10 to the 7th squared times 25, right? And that's c squared, so then I take the square root of this whole thing, and that should be c. Y'all follow me what I'm doing here? Class? All right, can somebody tell me what that is? We're gonna check this. I spent way too much time on this. Anybody? If you got a calculator?
Yeah, that's right.
What is it?
It's 63.34 picofarads.
C equals 63.34 picofarads. I mean, y'all follow me on this one? The problem was the understanding of the problem, and that's on me, because I should have known. I didn't catch that I'm asking a circuit to do something that is impossible. If you got an RC circuit alone, it can only go up or down by 20 dB per decade. Now, if it's an RLC by itself, then you can go up or down by 40 dB. After that, if you want to go more than that, you need stages of circuits. For this one, that's as good as it gets, is 20 dB plus or minus. And that is the value. All right, any other questions? I'll do you a favor, I'll even leave that up there for your quiz. All right, it's about that time. All right, I didn't get the cover because I was